In the last two videos, we've seen how to parse numbers and quoted strings. In this final video for this week, I'm going to show you how to write a slightly more complicated parser, which parses JSON values. So JSON stands for the JavaScript Object Notation, and it's a now extremely widely used common notation for sending data values across the internet. And so here's an example of it. So we have open curly brackets, and then we have a field name called f, this has the value 1, field name called g, and this is a list of 1, null, true, string, burp, false, and another nested list, and then a field name called name, which then has the list 4, null, 5, null, and an object with a field name a and 10. Now, what we're going to do is first make a data type for representing JSON values in Haskell. So a JSON value is either a number, and with a full JSON this is floating point numbers, but just for simplicity I'm going to keep it to integers here, or it's a boolean that can be true or false, or it's a string, or it's the word null, or it's an array, which I'm going to represent as a list of JSON values, this is a recursive data type, or it's an object which consists of a list of pairs of strings and JSON values, like the key value stores we've seen many times in this course already. And now what I'm going to do is work from the bottom up, writing parsers to parse each of these different kinds of things, and then put that all together at the end to write a parser for JSON values. So we've already seen in the last two videos how to write a parser for numbers and a parser for string values in quotes. So now let's write a parser for booleans and a parser for nulls. So let's write parse JSON bool. So we can't reuse our boolean parser from a few videos ago because in JSON true and false start with lowercase. So this is going to be a parser of bools, parse JSON bool, but it's going to work the same way as our previous boolean parser. So we're going to say is string true? If it is, then we return true, or else is string false, in which case we return false. And now let's test this parser. Oops, I've made a typo in the name of the function there, so it's lowercase n. So we run parser, parse JSON bool, lowercase true, we get back true, and lowercase false, we get back false, and anything else like a true with a capital T is a parse failure. Now the next simple one is just the word null. So this is just going to be parse JSON null, and then either we succeed in parsing null, in which case it's going to return just something underneath, or we fail. But there's no actual useful information we get back from a null. So this is going to be a parser that returns the empty tuple. So parse JSON null is just a parser which looks for the string null. Now we're going to go on and do the two slightly more interesting parts of JSON. The arrays, which are lists of comma-separated values with square brackets around them, and the objects, which are lists of key value pairs with curly brackets around them. So let's do arrays first. So an example array is something that looks like this. Open square bracket, then we have a list of JSON values, let's say 1, 2, null, false, blarp. And also, as an added twist, we're allowed any amount of spaces we like between the square brackets and around the commas. So we're going to have to watch out for that as well. So the first thing we're going to do is just write a simple parser which just parses spaces. Let's call this parse space. So it's not going to return any useful information, but what it does is it consumes the next character if it's a space. So parse space reads in a character. If it's a space, so there's a built-in library function called isSpace. So this recognizes not only spaces but tabs and new lines, and some of the other weird and wonderful Unicode spaces, like non-breaking spaces. If it is a space, then it returns the empty tuple, otherwise it fails parse. So this is a parser which only recognizes whitespace characters. And now we're going to write one called parse whitespace, what does that do? Well, it just parses 0 or more spaces. So let's test that. Of course, 0 or more returns a list, so we run that and then just return the empty tuple at the end. Right, so run parser parse whitespace will allow us to ignore any amount of space before we parse something else. So you can see here it's ignored all these spaces here and just returned the first non-space part of the input, and no useful value as its return value. Now, in lists, we have things separated by commas, and we already have this useful thing for 0 or more. But it's also useful to have a thing which takes a parser and then, given another parser for parsing the items, parses things separated by some fixed thing. So we're going to call this function setBy, and it's going to take a parser for the separator, which is going to recognize commas, and a parser for the values, and then it returns a parser which recognizes lists of values separated by the first parser. So does this work? So we take a parser for the separator and a parser for the items. Then, a bit like 0 or more, we read in an item, so we try and parse with p. And then we're going to do 0 or more occurrences of doing the separator followed by p. So the semicolon is just a way of writing do notation all on one line. And then return this thing at the head of the list followed by separator p, separator p, separator p, separator p 0 more times. If that doesn't work, then we just return the empty list. So let's see how this works. Well, let's first make a little parser for commas. So a comma says, is the character a comma? And now we can run parser separated by comma number. And now this will allow us to parse lists of numbers separated by commas. So we can say 1, 2, 3, 4, 5. And it will return the list 1, 2, 3, 4, 5, read from this thing separated by commas. Now, we can also check to see whether this allows spaces, which is what we needed for the JSON parser, and of course it doesn't, because we haven't written anything which allows spaces. So this one has managed to parse the first element of the list, but then after that it's failed because the comma parser didn't recognize a comma followed by a space. So the way to fix that is just to write another separator called spaced comma, which does parse whitespace, then a comma, and then parse whitespace. So this allows spaces before and after the commas. So if we separate by spaced comma, then we can write lists which have any amount of spaces between each element. Now we can put this all together to write a parser for JSON style lists. So as I said, a list starts with an open square bracket, some spaces, a list of 0 or more elements separated by commas, some more spaces, and then a closed square bracket. So let's write that. So we're going to write parse list. It's going to take a parser for the items in the list. we do is char open square bracket, some white space, then the elements of the list, let's call them items, set by spaced comma p, some more white space, and then end with the character close square bracket. And then at the end we return the items. So now if we do parse list number, we can parse lists which consist of numbers. If we do parse list parse JSON bool, then it won't work on list of numbers, but it will work if we do true, false, true. The next thing we need is a parser for JSON style objects. So what do these look like? So these look like something like this. Open curly brackets, a field name in quotes, a colon, and then a JSON value. So in many ways this is similar to the parsing lists. Instead of the open square brackets, we have an open curly brackets. Then each item, separated by commas, is now a pair of a key, which is a quoted string, and then a JSON value. So what we're going to do now is write something which allows us to use any parser for the actual values, and then we'll close the loop later on when we write it for JSON values. So parse object, first what we're going to do is write a parse object field, which parses the pair of a quoted string, then a colon, and then a value. So it's going to be a parser which takes a parser for A's, and returns back a parser which returns a string, which is going to be the field name, and the A value. So what does this do? Well, it takes the field name, that's a quoted string, then parses some white space, then checks for a colon, parses some more white space, and then parses the value, and then returns the field name and the value. So let's try this. Run parser for parse object field. So if we give it, we need to give it a parser for the values in the object field. So let's say the numbers. So that's a quoted string followed by a colon followed by a value. So that gives us the pair of the string, the field name, and the number. And now to parse objects themselves, well, it's going to look very similar to the list one, except now, rather than parsing just the items separated by commas, we're going to parse object fields separated by commas. So to parse an object, well, it's going to return us a list of string and value pairs. We start with an open curly bracket, some white space, and object field parser, then some white space, close curly bracket, and we return the items. Let's call it fields. So now we can test this one with parse object, where we're assuming that the values stored in the object are all numbers for the time being. So now this gives us a parser for objects as long as we can pass in a parser for the values stored in the object. So it reads an open curly bracket, then a field name, then a colon, then the value, a comma, field name, colon, value, and so on. And we can repeat this for as many times as we like. To get more fields. Now finally we have to wrap this all up by writing parse JSON. which is going to be a parser that returns JSON values. And now this is an exercise in writing a case for every possible kind of JSON value we can have. So the first one is we can parse a number, in which case we'll return that number with the correct constructor from the JSON type. If that doesn't work, then we can try and parse a JSON Boolean. If that doesn't work, then we can try and parse a quoted string. If that doesn't work, we can try and parse a null. And if that doesn't work, we can try to parse a list of JSON values. So we have the items, parse list. Now parse list takes a parser for the items which are in the list, and now we can use parse JSON itself, the one we're currently writing, to go on to parse later JSON, the JSON values stored within the list. So now we return array of items, or else if that didn't work, we can use our object parser to parse an object with JSON values in and return object with the fields. Oh, and this is called Boolean, or bool. So now we've got a test JSON string here, which is the one at the start, and we can test the parser by running run parser test JSON string. Run the parser parse JSON on test JSON string, and we can see here it's read in the data from this string. So it's recognized it starts with an open curly bracket, then there's a field called f, which contains number 1. There's a field called g, which contains an array, so this array from here to here, where the number 1, the null, the true, the burp, the false, and then another array with a in it, and then there's another field called name, which contains an array with a number 4, null, 5, null, an object. So you can see in just a 17-minute video, or 18-minute video so far, that we've been able to start from basic parsers for parsing numbers and strings, and build that up into quite a complex parser for parsing these JSON values.